Experiment 1. Determination of the density of water. Pre-lab. First, what do you need to begin the session? You need to have the following in hand. A laboratory manual, semester 1 and 2, DK014 and DK024. Pre-lab guidelines, DK014 and DK024. A pen, a paper, and an electronic calculator. Learning outcomes. At the end of this lesson, students should be able to determine the density of water and compare the accuracy of the density of water using different apparatus. First question that we need to ask ourselves, what is density? Density is defined as mass per unit volume. The unit of density is gram per milliliter or kilogram per liter. When temperature increases, the density decreases because density is dependent on temperature. For example, density of water at 25 degrees Celsius is 0.997044 gram per milliliter. However, at 30 degrees Celsius, the density of water decreases to 0.995646 gram per milliliter. To begin the experiment, you need to have the following apparatus ready. A 50 milliliter burette, a glass rod, a filter funnel, a 200 milliliter beaker, 3 pieces of 50 milliliter beaker, a 10 milliliter pipette, an analytical balance, a 25 milliliter measuring cylinder, a thermometer, and a dropper. Let's recap. This is a 50 milliliter burette, and remember, burette should be used with a retort stand. This is a filter funnel. This is a 200 milliliter beaker. These are 3 pieces of 50 milliliter beaker. This is a 10 milliliter pipette, and remember, a pipette is used with either a pipette filler or a pipette bulb. This is an analytical balance. This is a 25 milliliter measuring cylinder. This is a thermometer. And this is a dropper. Next, we need to ask ourselves, out of all the apparatus, which ones are used to measure volume of water? The answer is only 3 of them. They are the burette, the pipette, and the measuring cylinder. Next, how to conduct the experiment. We are going to determine the density of 10 milliliter water using burette, pipette, and measuring cylinder. Step 1. Label the 200 milliliter beaker as tap water and the 3 50 milliliter beakers as 1, 2, and 3. Step 2. Fill the 200 milliliter beaker with tap water. Step 3. Using a thermometer, measure the temperature of the tap water and record the temperature. Step 4. Using a barometer, measure the atmospheric pressure. Record the pressure. Step 5. Using the analytical balance, weigh the mass of the empty 50 milliliter beaker labeled as 1. Step 6. Fill up the 50 milliliter burette with the tap water from the beaker. Note: you can fill up the burette to exceed the 0 mark, then release the water from the burette slowly until it reaches the 0 mark again. Step 7. Release 10 ml of water from the burette into the beaker 1. Step 8. Weigh the mass of the beaker 1 containing the 10 ml of water. Step 9. Using the analytical balance, weigh the mass of empty 50 ml beaker labeled as 2. Step 10. Using a pipette and a pipette bulb or pipette filler, transfer 10 ml of tap water into the beaker 2. Note: you can fill up the pipette to exceed the 0 mark. Then release the water from the pipette slowly until it reaches the 0 mark again. Step 11. Weigh the mass of the beaker 2 containing the 10 ml of water. Step 12. Using the analytical balance, weigh the mass of the empty 50 ml beaker labeled as 3. Step 13. Using measuring cylinder, measure 10 ml of tap water. Note: when the volume of water is approaching the 10 ml mark, use a dropper to add water drop by drop. Step 14. Transfer the 10 ml of water from the measuring cylinder into the beaker 3. Step 15. Weigh the mass of the beaker 3 containing the 10 ml of water. To be continued. Experiment 1. Data Analysis.